Hi, in this lecture we are going to be looking at decision trees, a very popular and a very simple and a very easy to explain machine learning technique. So it is very popular because it is very simple and it is very easy to understand and easy to explain. It makes my job pretty easy in this particular course. So what happens in a decision tree is that again you have predictor variables and you have target variables. You use the predictor variables to build a decision tree. A decision tree is built where you keep checking the values of the predictor variables, and depending on the values of the predictor variables, you start making decisions. And based on that, you keep progressively making decisions until you reach the leaf node where you are actually predicting or classifying some data. So when you build this tree, the trees typically start at a root node, and then progressively there are some branches that keeps coming in. At each branch you keep asking a question or doing some logical comparison, and based on that making decisions and keep moving along. And then finally there are the leaf nodes which actually present you the decisions. Decision trees are a popular classification. It is mostly used for classification. It can be used on continuous data, but it is mostly used for classification purposes. So again, a training data is used to build a decision tree. The tree itself is the model in the case of decision trees. The tree is the model, and then the decision tree basically predicts the target, and then you use this particular model and then you predict for new data. So here is an example of a decision tree. On the left side you have data. So you have three variables. There is age and BMI. So age and BMI are your predictors, and then a variable called is diabetic, whether a patient is diabetic or not, is the target variable. And for this data we are going to be building a decision tree on the right. So in this case we start with age greater than 41. So that is the first question we ask ourselves, age greater than 41, and if it is yes, then we go and make the next decision, is BMI greater than 24. If it is yes, then the value of is diabetic is Y. If not, the value of is diabetic is no. Similarly, you build the tree on the left side also, and you see no and Y. So the tree actually becomes a model. So suppose you get a new data that you have to predict. Somebody gives you an age and a BMI combination, ask you the question, is this patient diabetic? Suppose let us say the age of the patient is 30 and the BMI is 40. So we can walk through this tree to make the prediction. So is this guy's age is 30, so age greater than 41, no. Come in this side. Is BMI greater than 28? Yes. So come in this side, and yes, that patient would be diabetic. So it is pretty easy to walk through the tree and come up with the solution. So the tree itself becomes the model, and then you use the model to predict on any new data. The challenge in building the tree is that in what sequence do you use these variables? How do you first determine, okay, I should use age here in the root node, not BMI. I could build this another tree with the same data where I start with maybe a question on a BMI greater than something, and then after a question on BMI, I can make a decision on age. But by using different variables and different sequences, so you can, in this two combination, you can use age first and then BMI, or you can use BMI first and age. You can build different trees, and different trees can have different levels. It depends on the complexity of the data that we are dealing with. Here the data is pretty simple, so it's only two levels. So trying to build a tree manually is not that easy. So there is a lot of complexity involved. Fortunately, machine learning algorithms adapt themselves to this complexity. They will figure out internally within their library which variables to use first, which variables to use second, based on the selectivity of these variables, and come out with an optimized decision tree. So you don't have to really worry about choosing these variables. So just pass into these algorithms the age, BMI, the predictor variables, and what your target is, and they build a decision tree and come out pretty quickly. And of course, when you do have to predict something, you just give the predictor variables, and the prediction algorithm just walks through the tree with the value supplied and comes up with a result. So again, reiterating what we saw, the depth of the tree is highly influenced by the sequence in which the predictors are chosen for decision. So sometimes the trees can end up really large, sometimes they are pretty small. It again depending on the number of predictor variables you have, the trees will be bigger or smaller. Predictors, using the predictors of high selectivity typically gives you a lot fast results. Again, the algorithms find them for you unless you are very eager to learn the theory behind all these algorithms. You don't have to really bother about these things. Machine learning algorithms, of course, they automatically make the decisions on the sequence and preference. So this is a pretty simple and straightforward machine learning algorithm, easy to build, easy to use, and easy to explain. So what are the advantages of these decision trees? First thing is they are easy to interpret and explain. Now, why this is easy to interpret, explain is a big thing is because, let us take an example that you're using a machine learning algorithm to build a model that is going to either approve or reject a person's loan. So it's a bank and somebody applies for a loan. You use a machine learning algorithm to look at the different attributes of the person applying for a loan, and then you approve or reject a loan. Now, if the person asks you like, why was my application rejected? Then you can actually easily look at the algorithm and tell him, okay, this is the reason why your thing got rejected, because it is easy for you to walk through the tree and then say at what points decisions were being made and based on what attributes, which attributes of him, let's say, is it age, is it income, is it past credit history, which one influenced his credit rating, and you can actually walk them through the tree and explain, okay, this is how we made a decision. It is not possible to do this kind of things with every other machine learning algorithm, possibly with linear regression, but not with something like, let's say, neural networks or support vector machines. It is not easy for you to explain why the algorithm behaved in a way it did. So this is pretty important, and it works very well with missing data. If data is missing, there are NAs. It is okay. It can handle NAs and work through that one. It is sensitive to local variations. What do you mean by sensitive to local variation is that if different ranges of the target has different phenomenon. For example, let's say you're trying to predict age, and in predicting age, for age 21 to 40, it is behaving in one way. So age 21 to 40 has a different behavior. Then age 40 to 60 has a different behavior. It adapts itself to this behavior. So it will build a tree where age less than 40 and then handle that behavior separately, and age greater than 40 and look at this phenomenon separately. Whereas if you look at something like linear regression, it is not localized. Linear regression, you have to draw a straight line anyway through all the points. So if there are local variations, the local variations are not adjusted itself in this linear model. You will see when you're drawing a line and trying to predict something, it will either predict this range 21 to 40 very accurately or the 41 to 60 very accurately. It can't predict both if they both have different kind of signals or they have different kind of patterns. But decision tree adapts itself pretty quickly to these kind of local patterns. And it is of course fast. It is pretty fast in building the decision tree. So model building is pretty quick. Why fast is an important thing is if you have to make real-time, you have to build models in real time for whatever reason, then this is one of the advantages. The shortcomings of decision trees are it has very limited accuracy. Accuracy is not that great with decision trees. Bias builds up very quickly. Bias towards a variable being some value. We already saw what bias is in the overview section. So bias builds up pretty quickly, and it is not good with a large number of predictors. If you have like 40 or 50 predictor variables, decision trees will not function that very well because it becomes difficult for it to find out which variable to use first and which variable to use second and stuff like that. Typically used in things like credit approvals, in situations where there are legal needs to explain decisions. So suppose you reject a person's loan application, that person goes and files a lawsuit saying that, okay, I was rejected for not so good reasons, or the rejection was biased towards something. Then you can use decision trees algorithm to explain why this particular person's application was rejected. So it has its advantages in these legal situations. and it is used for preliminary categorizations. A lot of, since it is sensitive to local variations, what it can do is first use this local variation to separate your data into 2 sets or 3 sets. So it is used for some kind of preliminary decision making or preliminary categorization. So you split the data using a decision tree, and then on each of the split you can go and apply some other machine learning algorithm. So split 1 can use algorithm A, split 2 can use algorithm B. So you can actually mix and match these algorithms as you want, and decision trees are usually somewhere upfront in the chain. You first split the data using decision trees, and for each of the splits you can apply different algorithms and come up with different predictions. So these are the advantages, shortcomings, and uses of decision trees. Thank you.